We are continuing to graph quadratic functions by using the different characteristics of the quadratics. Yesterday, I assigned y'all a worksheet and I just said do 1, 2, and 3 at the moment. So let me pull that up. When we look at the assignment from yesterday, we have a function 2x squared plus 2, and we're asked for domain, range, axis of symmetry, max, min, vertex, y-intercept, number of roots, 0 solutions, and then numerical value of our solutions. So for numerical value, that'll actually be what x is. On this one, there are none, so you will have none here as well, because we can't write what the numerical values are because there aren't any. On number 3, let's look at that one. Number of roots, 0 solutions. We're looking at how many times it crosses the x-axis. So it crosses it at 2 spots. So we would write 2, and then we would identify what those are. So it crosses at -5 and at +1. So we can write that as coordinates, or we can write it as x equals this and x equals this. So x equals -5 and x equals 1. If you want to write them as points, that's fine too. -5, 0, and 1, 0. Either way of writing it will be correct. Not very often or never have we gotten 2 answers for something. But the reason we get 2 answers for something is because that squared. When you square a negative number, what happens to it? Negative number squared is like saying -5 times -5, which changes it to a positive. So that's how we're able to get 2 answers, because we have a squared in there. Okay, the next one, let's look at this. When we have this next one, so you're going to finish the rest of this worksheet today. It says identify the key characteristics features in the graph below, then give the value of each feature characteristic. So domain, because this extends on and on, so we're going to extend it, right? Let's go and put our arrows there. For quadratic functions, if it is not restricted by an open circle or a closed circle, it is going to be all real numbers. The range is going to be how far down does it go, what's the bottom, to how far does it go to the top. So how far down does this go for the range? -2. So it goes to -2, and how far up does it go? Infinity. Because the arrows means it goes on and on forever. So it's going to go from -2 to infinity. So does that mean y is greater than or y is less than -2? Greater, because it's starting at -2 and it's getting greater. It's going up. So we'd say y is greater than or equal to, because it actually touches it, -2. The next thing I want to look at is y-intercept. Can we see a y-intercept on this graph?
No.
No. But is there one?
Yes, eventually.
Eventually, yeah. So this is where we'll want to find or use our calculator. Let's go to our calculator and let's put it in. So we're looking for the y-intercept. Does anyone have any idea of what they think it might be? It's going to go on. Okay, so we'll graph it. Oh, I'm still zoomed. So I'm going to hit zoom standard. So we could look at our graph. Remember on our EOC review, we were asked for the y-intercept? How could we use the table to find the y-intercept? Huh? How could we use the table to find our y-intercept?
Find where x is 0.
Yeah, find where x is 0. So I would go to table, x is 0, y is 30. Okay, so on your notes that I'm going to have you take right now, I want you to write y-intercept. That is found. Look at the table. Where x equals 0. X, y. So we have where 0 is x, this is your y-intercept. We could also look at our equation and see our y-intercept is actually the c value in that ax squared plus bx plus c. See how that's the 30 right there? If I were to plug in 0 right here, everything would zero out. 2 times 0 squared is 0. Minus 6 times 0 is 0. Plus 30 leaves us with 30. So that's how you could also get your y-intercept. Okay, we're going to put our assignment away for now. We'll come back to it. I want y'all to go to slide number 8. On slide 8, this is talking about graphing quadratic functions notes. So the first step, these steps can go in any order you choose. This is just the most logical for me. So you could do it a different way, that's fine. The first thing you would want to find is your axis of symmetry. And that is using the formula x equals negative b over 2a. In our formula chart, you won't have to memorize that formula because we have it right here. It's the very last formula on your formula chart, negative b over 2a. You can easily find your axis of symmetry by using that. So on our notes, we're going to write the standard form because that's where we get our a, b, and c. Ax squared plus bx plus c. It should say y equals. And the a, b, and c could actually be lowercase. I don't know why I did uppercase. So to find our axis of symmetry, AOS, we'll use the formula x equals negative b over 2a. So we are going to use our first example. So example 1 is going to be y equals x squared plus 3. And we are going to find the axis of symmetry. Here we don't even have all the parts to it. We don't have 3 terms. But we could rewrite it to say y equals x squared. There's no b, so we would say 0 for b, so 0x plus 3. These mean the same thing. The only thing I added was a 0x for our b value. So for our axis of symmetry, we'll say x equals negative the b value. So what is the a value? Let's find that out first. What's in front of x squared? 1. What is the b value? And the c value? So when we use our formula, x equals negative b, so negative 0 over 2 times 1. What is that going to actually be? 0 divided by anything. 0 cookies divided by 5 friends? 0. So x equals 0 is our axis of symmetry. So let's graph it here. I think we might have, yeah, we have a line that we can drag over. So put it over where x is 0. Bless you. So it's a vertical line that cuts the parabola in half. And let's go ahead and type in here, x equals 0. The vertex. It says find the vertex by plugging the axis of symmetry into the quadratic equation. So we would plug in 0 for x to find our vertex. Plug in AOS, axis of symmetry, into a function. So our AOS is x equals 0. We can use our original. We don't have to use the one that we had the b. That was just to find our a, b, and c. So it'd be y equals 0 squared plus 3. So then y equals 3. So our vertex is when x equals 0 and y equals 3. So our point is 0, 3. So we'll put that here, 0, 3, and plot a point there. So over 0, up 3. Then the y-intercept, we already talked about that. It's when x equals 0. Do we already actually have the y-intercept here? We do. It's right here. So our y-intercept, and this one is the same. Not always is that true, though. 0, 3. Now let's use our calculator. So let's put in our equation. So y equals x squared plus 3. Let's graph it. So we have the vertex is here. It's going down the x the y-axis. We need a few more points so we can graph it on our paper. So let's see. Move this over. I need a few more points. So where could I find some more points to plot? Yeah, the table. So second table. Okay, so 0, 3 we already have. 1, 4 is one more over. So let's plot that one. Over 1, up 4. I went up too far, didn't I? There's 4. And that axis of symmetry tells us that you can reflect this point to the other side. So if this point is 1 unit from the axis of symmetry, then you would go 1 unit to the other side because it's a mirror image. Does anybody watch Flash? Yeah, they just have been talking about and going through the mirror verse. It's like the same universe, but it's flipped, and you can see people through the mirror. It's kind of weird, but that's what it makes me think of. Then the next one would be 2, 7. So over 2 up to 7. I'm going to grab another point. 1, 2, up 1, 2, 3, 4, 5, 6, 7. And then flip that over to the other side. Over that axis of symmetry. And then grab the little parabola. We're going to go make that parabola follow those points. As best as you can. It's not going to be perfect, but not too bad. There we go. So for the domain of the quadratic, there's no restrictions here. We don't have any points saying it only goes to the left to 5 or anything like that. These arrows say that's going to go on and on forever in both directions. So our domain is all real numbers. And then with our range, it is how far down does it go to how far up does it go. So how far down does it go? +3, and then how far up will it go? Infinity. So it's going to start at 3 and get larger. So y has to be greater than or equal to 3. You can use the symbol, or you can just use a greater than symbol and underline it. Give the maximum or minimum value. What do we have here? Do we have a maximum or a minimum? Minimum. So I'm going to circle it or underline it. And the minimum value for this is how low does it go? And it's only the y value. So how low does it go? The lowest it goes is 3. So we would just put 3. That's our minimum value. How many root solutions, x-intercepts are there? Do we have any? No. So none. So over here, I do want us to write min or max. If our parabola is upward, like this, we have a minimum here. If our parabola is downward, then we have a maximum here. And it will just be the y value of the vertex. So an easy way to find it is just look at what is the y value of the vertex. So on this example, the vertex was at 0, 3. So our minimum value equals 3, because this is x, this is y. And our axis of symmetry is actually the x value of the vertex. So AOS, x value of vertex. And you write it as x equals whatever that number is. So now your assignment is to finish the rest of that characteristics of quadratic functions practice.